Welcome all of you. Good morning, Karthik sir. Good morning, Naveen sir.
Good morning, ma'am.
So shall we start the session, sir?
Yes, we can.
Yes. Good morning, one and all present here. It's a great pleasure to welcome you all for the 24 hours national level online hackathon on sustainable energy in association with OpenViewer. This event was conducted by PIT IAMP student chapter supported by IAMP. And we have the nodal officer for IAMP Coimbatore chapter, Neela Meghan sir, who is a retired electrical engineer with 32 years of experience in manufacturing industry, and he is holding a C certificate issued by Government of India. He is certified energy manager and empaneled the external faculty of PCRA. We welcome you, sir, for joining with us on the inauguration of this launch program. Neela Meghan, sir.
Thank you very much.
Yes, sir. Now, since it's going to be the hackathon event, we would like to have the few words about the open source and OpenViewer software. So about OpenViewer, it is having a mission to reinvent digital realization, and OpenViewer's developer tools combine the vast knowledge available in open source and cloud with AI to accelerate the application development. The developers jumpstart their application development on Candy by OpenViewer. Candy kits help developers build applications faster from ready-made solutions. Candy also helps the developers augment their solutions through specific reusable libraries, packages, APIs from over 430 million software knowledge items. And developers also get code snippets, how-tos, question and answers, common fixes, and documentation to integrate the libraries into their applications. And to elaborate this, we have Karthikeyan Krishnaswamy Raja sir with us, who is the CTO at OpenViewer, and he has extensive experience in technology architecture, enterprise transformation programs, and product design. He has worked with various technology platforms with AI for intelligent automation and high-performing enterprise business systems for different industries spanning across banking, manufacturing, healthcare, retail, and logistics. Now I request Karthikeyan sir to take over the session and elaborate the participants, please.
Thank you, ma'am. Just I just want to check if my audio and my screen is good.
Yes, sir. Yes, sir.
Thank you. Yeah, first of all, a very warm welcome to all of you who are joining us for this inaugural session of this hackathon. And I thank VIT University to take this initiative on arranging this hackathon on such a great topic. And we are also very happy to be partnering with VIT on this particular initiative. So before we get started on the hackathon, I just wanted to give you a broad perspective of how open source has been changing the course of application development over the many years, right? So open source has been there since very long time. It has been there since probably many of us were born, right? And one of the most popular open source is our Linux operating system, which turned 30 years last year, 2021 it turned last year. And it's been impossible for anyone to ignore open source as such. It has been always there, present in the technology world, always growing along these many years. That today, if you see, most of the softwares are existing with one or more than one open source components. Okay, it's right from your smartphone. You take the Android operating system to all the way to NASA's rovers on the Mars. They contain open source software. Okay, And even the very popular public clouds from Amazon, Google, Azure, all of them also use this open source technologies in their cloud platform. So any application that you create or you come across, 90% chance it is actually having a lot of open source components. And that's how open sources has been changing the way applications are built, the which applications development has been accelerated also. So if you take some peek into history, like earlier, how do we used to create those applications? So when I started out as a developer, right, and just to give you an example of creating a web application, okay, which is the most common thing that's done today. We used to have to create the framework for front end. We had to create the framework for back end. We had to create the framework for security, login, every small thing, like even creating a menu item that you see now in such a variety in all these web applications and mobile apps. We had to create those frameworks right from the scratch. Okay, so anything to do with even databases, okay, we had to create a framework for it, okay, so that it follows the best design practices and stuff. And whole gambit of application stack, if you see, was repeated across different teams. So you can imagine how much of time would have got actually wasted globally because of we having to do the same thing again and again. But that's how the open source has been changing the whole concept of reuse as well, right? So it has been growing since long. All of the items that I spoke about as far as the application stack and many other software stack has been growing in the open source world. And today there are millions of such developers who actually create these open source frameworks that is available to all of us to actually reuse and make our whole application development much more faster. Okay, so today I don't have to worry about understanding the best design pattern for web application framework. I can go and choose the Spring framework, for example. You have a lot of UI frameworks like React, Angular, all of those things. And this open source is present in all stacks. Okay, so if you take a typical data center, so where your applications run, so right from the operating system, right, the Linux versions, to network, to storage, to your security, to your databases, so all such different stacks, so application stack, anything that you take today has a great option in open source, which is very widely used. Okay, so there are at least 300 such different stacks that are available today, which is very popularly used. So you can imagine how much acceleration that actually gives us, how much innovation we can do, right? I mean, if you take it any topic from artificial intelligence, you have a lot of frameworks that are open source. You take the topic of augmented reality, virtual reality, blockchain, cryptocurrency, any hot topic that you take is very much powered by this open source component. So a lot of options for us to reuse, accelerate our whole application development, and then make very innovative solutions very much faster than we used to do earlier. Okay, so if you see where these open sources are available to us today, right? Majority of this open source components are available, as I said, as frameworks, scripts, libraries. All of them, majority of them are actually available in multiple repositories. Okay, so majority is in GitHub, which has this different frameworks and libraries depending on the use cases that you are looking for. And then the SourceForge has been there for quite some time, which actually was focusing more on kind of fully packaged applications. Okay, they're open source, but fully packaged applications could be like a CRM application or any other Windows desktop applications, all of those things. So you have a huge variety. You have a very discrete, very atomic scripts that are there. You have full-fledged applications also available, and a whole spectrum of open source community to support as well. The numbers, as you see, is mind-boggling, right? I mean, over 40 million repositories and over 500 million knowledge items. So what we say is that anything that you use as a open source item, you will have to understand how to install it, what are the example use cases, what are the example code snippets. So much of knowledge is associated with each of this open source item that is also available to us through all of these repositories. Okay, it's not only very horizontal technology oriented stuff that is available as open source, but even full-fledged industry domain applications are also available, and it is led by majority on the telecoms and media. But all industries have their representation. So if you take retail, for example, you have a lot of open source e-commerce applications. So similarly, under manufacturing, utilities, energy, healthcare, they have their own business applications also available as open source, right? And it is also ever growing. There's so much of contribution that is happening daily, so that if you want to start something in your industry domain, it always makes sense to see what type of use cases, the business use cases are also available, and we can use that to actually jumpstart our business application development on that particular topic. So with so much of open source available, there's millions of choices. So how do we select, right? And these are some of the factors that we should keep in mind when we try to select the open source components. Okay, support is number one, because open source you use, which is not developed by you, right? There's a whole community that probably developed it, and we need to see who are the people who are supporting. Is there an active community that is supporting it? Do I get answers to any queries that I ask? Do I get quick fixes to any of the bugs and patches that I request for, right? So like that, there are at least 5 very critical parameters to be looked at when we try to use open source, right? Support, quality, and what type of license that it has, right? The license also plays a major role. Again, in open source, there are different type of license. One license group allows you to commercialize, distribute as you want. Another license type actually, allows you to freely use it. But if you make changes to the, library or the framework, you have to release it back to the open source world. So license is something that you will also have to watch out when you want to use open source in case you want to commercialize and distribute as your own application. Okay. Last about us, I think ma'am covered us in a very nice way. Yes, so OpenWeaver, we are a very young startup. We just started about couple of years back, and as you said, our primary focus is to bring a lot of developer acceleration tools so that the whole life cycle of building applications is much faster through open source. Okay, so we believe in open source a lot. Our whole philosophy is built on open source, and we want to uh, ensure that the whole knowledge that is available in the open source world is made available to all these developers. And that's how we launched Candy as our first tool. Sometime last year March we launched, and we are also having very happy to say that we have 1.3 million users who have experienced Candy now. So with that, I once again welcome you all to this hackathon session, and I wish you very best. I'm very eager to see tomorrow what kind of exciting solutions that you will come up with. All the best to you all. Thank you. Back to you, ma'am.
Thank you, sir. Thank you, Karthik, sir, for your wonderful introduction. Now I request Naveen, sir. Naveen Kumar, sir.
Hi, Naveen, are you on mute by chance?
Next, I request Arul Regan sir to take over the session, please, from OpenViewer.
Yeah, hi, good morning, all. It will be Ganesh who will be doing the next section. So,
Yeah, please.
yeah, Ganesh.
Good morning, Ganesh. Ganesh, are you able to share your screen?
Hi, Karthik. Hi, team. Hi, everyone. Yeah, let me do a quick check. Are you guys able to see my screen?
Yeah, we are able to see the screen and hear you well. Yes, good to go ahead. Thanks, Ganesh.
Okay, thanks, Karthik. Okay, let's start. So, to all fellow students and faculty, very good morning. Today, myself, I'm Lakshmipati Ganesh. I'm a senior software engineer in machine learning working with OpenViewer. Welcome you to the Rapid Hacks Hackathon event. This event will be, I'll be covering mostly on the autonomous perspective of so machine learning solution making use of open source. To start with, the agenda would be we'll go through what artificial intelligence is and then slide on to what does AutoML do, and then do a hands-on solution, kind of demo solution for the hackathon data that we have built with Candy. We'll be going through the starter kit as well. So let's proceed. So to start with, we'll start with artificial intelligence. So artificial intelligence is the field where intelligence is acquired by machines artificially, as in like we humans are being trained from our childhood to have intelligence, telling that okay, this is right, this is wrong, identify something, okay, this is a cat, this is a dog. But machines need to be fed those information to actually analyze specific information and then come up with the output. So that is where artificial intelligence comes into play. When we broadly see on artificial intelligence, there are many ways, or I would say many different parameters or of acquiring artificial intelligence for the machines. So one is a typical simple plain rule engine based implementation, wherein we'll be feeding the machine with specific hard-coded rules telling that okay, if it follows this particular criteria, it can be classified as a dog. If it follows this particular criteria, it can be classified as a cat, something like that. But then the limitation of being a rule engine is it cannot foresee predict the unforeseen data that efficiently, because it will be totally governed by hard-coded rules. That's where machine learning and deep learning comes into play. So when we consider machine learning and deep learning, we are typically training the machine with vast amount of data that has features for defining a cat, features for defining a dog, and then we'll be going ahead with deep learning as well. Deep learning is kind of an enhanced version of machine learning, wherein we'll be feeding more data for the machine to learn, and the inference could be comfortably better as well. When we talk about machine learning, typically there are three main techniques. So we'll be covering two here. So one is supervised learning. Supervised learning is when you give the machine the training data with all the input features. Let's say you give an image of a cat, and after the image, you do some processing of the image, and you give all the vectors or the numerical values of each pixels of that image, and then map it to a target label, which is being cat or a dog. So let's say a particular features define a cat and particular feature defines a dog. So we kind of collect many images, feed it into the model, and train it, telling that okay, if it follows this pattern, and allow the machine to infer, telling that if it follows a certain pattern, then it becomes a cat. If it follows a certain pattern, it becomes a dog. This is where supervised learning comes into play. Then we look ahead and move on to unsupervised learning. So with unsupervised learning, it's like we don't have to initially train the machine with the target. So the machine itself identifies the patterns inside the image and itself clusters together all the nearest values and then gives out that if it is a dog or if it is a cat. So these are the broad perspectives of artificial intelligence. Now moving on ahead, we'll see on AutoML. So standard practices have been, when I started my career before some 5 years ago, the AutoML was only starting to almost about to start. What we used to do is we used to get the data. Once we gather the data, we'll do some pre-processing, analyzing all data types, and then do some exploratory data analysis on top of that. And after some feature engineering, we'll have to do every steps mentioned here manually. But with AutoML, the advantage is being there has been a pipeline that is already in place, wherein you just have to feed the data and the AutoML takes care of all other steps. So the steps being initially data preparation and ingestion. This is the only thing we would be feeding into the model or into the AutoML pipeline. So once we pass in the data, the next step would be feature engineering. The feature engineering is where an AutoML engine would automatically infer all the schema of all the columns. Let's say you needn't have to mention the data type at all. Once you feed in the data, it will automatically identify if it is a numeric column, if it is a categorical column, or if it is being any datetime column as well. So it will automatically infer the schema, and the only thing which we need to do is after the schema inference, we might have to do a bit of validation, seeing that okay, if the schema or the data type has been identified correctly. Most probably for all the times I have worked with, it has grown to a substantial level that it correctly infers schema for all the columns. And once the schema has been inferred, then the next thing would be like to do necessary pre-processing steps. So pre-processing comes into play as in like, let's say there are many categorical variables. So there has to be a treatment for categorical variables. And let's say if the target is being labeled as text, as in like good or bad, then there has to be a label encoding for the target for the algorithm or the machine to understand, right? So we typically do it ourselves, as in like convert the good to be a label as in like 0 and convert bad to be a label as in like 1. Here the machine automatically, the AutoML pipeline does that as well. It categorizes the target column or into specific encoding, and if there are many levels or multi-levels in a particular column, let's say high, low, medium, all values are present in a single column, we'll do all encoding manually if we are doing it without AutoML. By using AutoML, all this will be taken care of, one-hot encoding. So whatever you name it, all pre-processing steps are already available in the pipeline that will automatically run once you ingest the data. Then there is also an option wherein you can have, there are multiple parameters there, wherein you can say, hey, I want this specific pre-processing step to be done on top of the default values. Let's say if there is a class imbalance in your data and you want to address it, there can be any parameter there which could be defaulted to false, and you can change it to true and run the pipeline. So the machine will automatically take care of the necessary steps or techniques to counter the class imbalance. So once we are done with feature engineering, the next step comes into model selection. So the prime advantage of AutoML here is being the model selection. The reason being, if it drastically reduces the time for selection of models if we have to do it manually. Because what happens with manually is once we have the data, let's say we split it into test and train data. So once we have the data, we'll have to do the modeling for each model separately by ourselves and then come up with the final selection based on all the metrics. However, what this AutoML does is once we just feed the training data into the pipeline, it just computes the model for different algorithms. So different platforms support different algorithms. Typically, there are at least 10 different algorithms for each use cases, be it regression, be it classification or clustering. So for each, there would be different algorithms that are already available. So when you go through the model selection pipeline, it will consume the training data and then compute, or it will internally convert it into a test training and validation split, typically how we do with the classic machine learning techniques. So it will then train on the training split, and then on the validation split, it will just validate or predict, and then finally give the output for all the models with the evaluation metrics. Let's say if it is going to be a classification based model, it will have all metrics across all models for accuracy, AUC curve, precision, recall, and so on. So the prime advantage being is we could select the model which gives us the best accuracy without even actually building different models. So then what we could do is at the end of this model selection, the AutoML pipeline would suggest us the best model, telling that, okay, if you use this model with these specific parameters, you could go ahead and build a test set or a validation set that can give you this level of accuracy. So we can consume that model right away and then proceed with the next steps. The next step being ensemble. Ensemble is where if you want to build additional models, let's say 2-3 models stacked together, you can do it and see if it actually improves the model accuracy. And then we can come ahead with hyperparameter optimization. Let's say we have, once the model selection step is complete, we'll be having the best model, right? So what we have to check in this hyperparameter optimization is when it runs across different algorithms in the model selection process, the hyperparameters for each algorithm would be to a limited range because it has to run through different algorithms and the computation would be huge. It has been limited to a definitive default ranges. With hyperparameter optimization, we'll be concentrating exclusively on the best model which we have just chosen in the model selection phase. So once we have the best model, what we will do is we'll increase the ranges of all the hyperparameters specific to that particular model. Let's say the model selection step gives me an ADA boost to be the best model. What I'll do is in hyperparameter optimization, I can tune the model more, and this hyperparameter ranges, all the parameter ranges are already available in the AutoML pipeline, and we can override it by providing our own manual values as well. But quite far or quite great ranges are already available in the pipeline. We just have to call a specific method, as in like a tune model. Then what we will observe is on as the output is being another, it will go through a cross validation for the validation set which we already have using different parameters of the ADA boost model which we got from model selection. So among these different ADA boost models with various hyperparameters, if by any chance has there been any better performance compared to the model which has been selected already in the model selection step, it will suggest that. Else we'll go ahead with the model selection step model. This we can, you'll be able to visualize it clearly once we get to the hands-on session. Then what, after hyperparameter optimization, what we'll do is we'll have to choose what are the levels of or different evaluation metrics we have to actually compute for the test data. So we'll be proceeding with the prediction on the test data, and then kind of have an user interface or a visualization chart for viewing different prediction levels. If we consider a classification based problem, then we'll have we can get a confusion matrix, we can get an AUC curve, everything plotted, and there will be, if it's a regression problem, we'll similarly have different plots, scatter plot, whatsoever available already. So this is the entire pipeline of the AutoML process, and it simplifies the manual process to a drastic level, and that's the reason we'll be proceeding with the demonstration of an setting up an AutoML pipeline today. Then we come ahead with what are all the different possible libraries that are available open source for the developers to actually build an AutoML solution. So this is just a snapshot of our of the kit that we already have on Candy. We have built it. So we could see here there are different libraries that are already available. So H2O is one popular library, and PyCaret is another popular library. There are other libraries as well, kind of like AutoSQL and AutoPyTorch, which kind of does or facilitates the automatic machine learning process. We'll be taking into consideration of PyCaret today, implementing a hands-on solution in PyCaret. So what we will go ahead now is we'll go ahead and create a solution which we have already made for the for this tailored to this particular session. So yes, we could we'll go ahead and experiment that with Candy.
Thanks, Ganesh. Just one thing. So I just wanted to also add, Ganesh, that earlier when we saw there are about more than 40 million open source repositories spread across those different GitHub, GitLab, and other such repositories, right? And we also have to watch out for those 5 different aspects when we want to use an open source. I think Candy makes it much more easier for all of us, so that you just come to Candy. You don't have to go to those individual places and then search for your needs, but you can use the Candy's search interface to search for your use case needs. For example, if you search for AutoML libraries, you will get the list that Ganesh just showed you earlier, and they have those different aspects also scored, like against a rating of which is good and which is not so good. So you get to get a view of the top libraries that are ranked. You also get to see a view of the dimensions of which are the best scores for support, quality, and security, and that allows you to make the whole process of choosing the library or the framework much more easier for all of us. Yeah, thanks, Ganesh. Back to you.
Thanks a lot, Karthik. Yeah, exactly. So the advantage of using Candy is we don't have to go on search in GitHub or other on the internet for finding open source library to build our solution. Candy is a one-stop platform wherein we have a total repository of almost 40 million libraries that are open source, being tested and done some validation as well. So I'll just quickly demo whatever just Karthik just told. Probably if I want to search libraries that are performing AutoML, I could just go to this find libraries pane and then type AutoML, and what we see here is a list of all libraries that are that perform the AutoML feature. And we kind of have different validation or I would say attributes for each library, which are thoroughly done checks and validated on by our developers to ease other developers in choosing the right library. So we have evaluated the support of this library, then we'll have evaluated the code quality of this library. Then the prime aspect being here is the license. So if we have to choose an open source library, we'll have to make sure that if it is a permissive license or it is a copyleft license, so only then we can use it on our own solution and then kind of redistribute it as well. So based on these parameters, we can go ahead and choose a library. And for those who are already not aware of Candy, you can explore, sign up and sign in and explore Candy. And there is also a product tour that is available, which gives you an overview of what Candy is and how to create a kit. So before we go ahead with it, I'll just say what a kit is. So we can go ahead and see a sample here. So this kit, which we just created, is tailored made for this VAT hackathon. So a kit is a collection, kind of a solution of with the solution of all possible libraries which can be used to solve this particular use case. So here it's an energy use case, right? So when we want to solve an energy use case, we'll go ahead with what are the libraries supporting specific functionality. Let's say if we have to go ahead with data exploration and dashboarding, there are different open source libraries that are already available, which we can go ahead search like how we did on find libraries and then add it to our kit. So it has been added now in this particular kit. And then if you want to do machine learning, we can find all libraries which are doing machine learning, then add it here. And if we have to do data annotation and labeling, there are libraries which could be added here pertaining to data labeling. And then what we'll have is a solution. So this kit will have, all kits predominantly has solution as well. The way you have to submit your entry today is also by adding your GitHub repo here. That will automatically get pulled in this solution source, wherein you'll, once you go inside this, it will redirect you to the GitHub repo here. So you'll have a GitHub repo which we just created, AutoML starter. So here the AutoML starter repo has been monitored by Candy, and then it has all the features of that has been displayed here. So coming back again, what we'll have to do in this session is, what we have to do, what we are going to do is we'll just see how we can reuse this particular kit or the solution we just built, making use of this kit by Candy for solving our classification use case of energy. So yes, the initial step being, we'll have to clone this AutoML starter repository from the particular GitHub. You could all go ahead and clone it if possible as well. For demonstration purposes, I have already cloned it, and it is already available in my environment. I have it cloned as AutoML starter. And once you have it, the next step would be install the required libraries by pip install requirements.txt. So we go inside the library, and then we typically run pip install, just copy paste from here. And then run it. So what it typically does is it kind of installs all the required libraries that are needed to solve this particular use case today. And since I've already tested it, it's already in my environment, so it's been already satisfied. Once you run this, your all the required libraries for building this hands-on solution will also be implemented in your environment. So once we have the libraries installed, the next thing would be we'll have to navigate to the AutoML classification Python notebook and then run itself. So we have the notebook here. We also have an H2O solution built up for, but for this use case, we are proceeding ahead with PyCaret. If anyone wants to experiment with H2O as well, what we have to just do is the requirements have been commented for H2O. You can go ahead and uncomment it and experiment yourself as well. So you can see it here. We have just commented H2O library from being installed because we'll be experimenting only with PyCaret. But you're free to uncomment this and then install H2O as well, and then run the energy H2O notebook. Great. So now we start ahead with, we'll start with what the use case is and what is the data that we are going to solve. The data that we are going to use is an IoT data of a manufacturing unit. So yes, so for our use case, we have thought about taking target to be detergent quality, which is basically a good or bad. So all the other columns are typically sensor data from an IoT setup, which kind of attributes to what the quality of the detergent is. So we'll go ahead and we can go ahead and load the data and then explore it and solve it, build a solution, a baseline solution, making use of AutoML through PyCaret. Okay, let's start. So what we typically have to do is, yes, just for viewing the dimensions, I kind of import pandas and then load the data which is inside the data repository or data folder. And then I see the dimensions of the data. So there are typically 122 columns and there are 1000 rows or observations. And we'll just view what we just saw here. Let's say what are the different, the top 5 rows of this. So there are different columns here and the target being detergent quality. Yes, and we kind of, this is an experimental, this kind of a setup, especially for Jupyter Notebook, wherein you just visualize the maximum rows. So typically if there are it won't display more than 20 rows, yeah, so not more than that. So if you have 1000 rows, what you will just see is the first 10 rows and it will be dot 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 and the next 10 rows. So I've set it to be none so that it will become easier for us to interpret later. And then we'll just see what the target or how the target distribution is. So as we see here, there are 2 unique values, right? So 2 unique values being good and bad, and the frequency of good being 775. So the entire data has 775 instances of good outcomes and only 225 instances of bad outcomes. So when we say it, it's kind of like an imbalanced data. So if you want to make a solution out of it, you can include or you have to handle the class imbalance so that it gives a very better result. If you don't handle it, it will still give you a result, but if you handle it, it will be really great. Then what we do is we kind of split it into train and test data. So for demonstration purposes, I've just taken a 90-10 split, and we have subsetted the first 900 observations in train data and the last 100 to be in the test data. Then now we'll go ahead and start with the AutoML pipeline. So since this is the classification problem, we'll be importing the classification module from PyCaret. Once that import is done, we'll go ahead with defining what the target variable is. So target being here, it is the detergent quality, which we just saw here. The name of it is detergent quality. And the data that we have to use for training is the train data, which we just subsetted in the previous step. Okay, so now we have defined what the target and the training data is. Then we'll have to go through all different pipelines of an AutoML engine. So PyCaret as such typically has 5 different steps. The first being a setup pipeline, where it will where it will get the data, and then it will infer all the schema and do necessary pre-processing steps, and then get the data ready, pre-process data ready. So that is the prime outcome of the setup pipeline. Then we have the next step being a compare models pipeline. Here there will be all the models will be compared, and the best model would be displayed. Then third comes the tune model, wherein for the best model, we'll do hyperparameter tuning to find if there are any even better model available. And then once we have the tuned model, we'll have to finalize the model, as in what model are we going to use for prediction? Is it the best model of the compare model step, or is it the tuned model of the tune model step? So we'll have we can finalize the model there in the finalized model step, and then we'll use that model for prediction. So this is the entire 5 steps that are already available in the pipeline. And essential step, just a note for here, we'll be proceeding with the setup pipeline or setup step as of now. The essential thing here is to validate the inferred schema. Predominantly, it typically infers the data type of a particular column correctly in most of the cases. I'll just make a note here. There has been an exception due to a minor bug in this PyCaret repository, which is up for patching and release in the next release. So I've just made a note here. In case if by any chance if you run the setup step and you face an error like illegal month error, what you have to do is you'll have to just change this session ID. What this session ID does is it kind of stores all the parameter. I'll explain more. So once you go inside the setup step, what you are doing is we are loading the data, right? So the load data being train data here. So the setup step, initially what it will do is it will kind of internally split it into train and test. So this is kind of a validation set for us considering the entire pipeline. But for the setup step, it is kind of a test. So it converts internally into 629 rows and 271 rows internally. It's a 70-30 split internally. And once we have the split, what this session ID does is, once you mention a session ID, this is kind of a random seed which we give for an algorithm. So all the rows that are already in train all the rows in test will be reproduced for a specific session number. Let's say if I give 90 here, the train and test data will be shuffled, and it will give a different subset of train and test internally for this setup pipeline. So I have gone ahead and set the number to be 100. This 100 isn't universal, so it will vary for you. You can keep any number you want. If by any chance you face an error, you just have to change a number for it to actually do a reshuffling of the data and then give you the get you out of the error. So another parameter which I've just given is fix imbalance. So as we already saw, we had a class imbalance here, 775 being good and 225 being bad. So we have to handle it. So I've gone ahead and set the fix imbalance parameter to be true here. If we go ahead and set it up true, it will handle by different techniques that are already available. SMOT is one popular technique that is available for class imbalance. So by default, we are using SMOT here. That's the default imbalance handling method. And then I've also gone ahead and given a feature selection to be true. So since there are 121 predictor columns here, the target being digit quality, I don't want all the 121 columns to be fed into the model because we don't want the computation time to be huge. What we just want to do is, before sending it to the model, we'll just have to figure out what are all the variables or essential or mostly correlated or attributed to the target. So we'll do this AutoML pipeline automatically does that feature selection and feeds those parameters onto the onto the model for modeling, for comparison of models. Yes, so I've set these two. These are parameters. You can set it to be false, you can set it to be true. We'll go ahead and execute the setup step here. Once you execute it, it will give you all the data types that are being inferred here. So if we are correct, we will go ahead and press enter here. This will typically, most of the cases, it will just give me the correct output or correct inference schema. Yes, so what we see on the output here is basically a definition or a summary of what just happened. So what we could see, this specific target variable has been label encoded automatically. So it was good and bad. Now it has been marked as bad being 0 and good being 1. So the original data size was 900 cross 122 columns, and there has been some missing values. It has identified that automatically, and how many numerical features are there, how many categorical features are there, how many ordinal features are there. So once this is done, we'll come to the transform, train, and test set. So what do you mean by transform, train, and test set is? So there are different categorical variables here, right? So there are 31 categorical variables, and there will be different levels inside these categorical variables. So it will automatically, typical machine learning step would be encoding those different levels in each categorical variable. This AutoML pipeline from my PyCaret does this automatically. So your 122 columns now has become 272 columns after different categorical encoding as well. So that's a great thing for us, because we don't have to take care of all this encoding stuff manually, and this does it by itself. And the others are being typical output of what it is. And if we see here, is there any collinearity in the time series data? This is an IoT sensor data. If it is there, it will just tell that it is true, and if it has handled it. And feature selection, we have set it to be true. And then fix imbalance, yes, we have just fixed the imbalance making use of SMOT technique. So this is the output of the setup pipeline. We have just completed it. So we'll have a transformed train set now with 629 rows and 272 columns. We'll just go ahead and execute the next step, which is compare model step. So in this compare model steps, there are different models that will be compared after being trained and evaluated on. We'll just allow it some time to run. So based on your computation power, you have an option to choose only specific models to be run. So currently, I've kind of didn't specify any specific models to be compared. I've just compared every model that are already available. So there are close to 11 to 12 models that are already available, and I'm going ahead with evaluating it for all of them and then comparing the best model. You could choose in the parameter here. You can just, if you want to know what are all available already as a parameter, you could just go for help, as in like you could just type let's say question mark and then compare models, and that will give me all the help documentation, which will have all the parameters and what does it mean and what you have to do to include or exclude specific columns. Okay, or specific algorithms. Yes, and now, okay, the output of this compare model step is a data frame which has all the algorithms that has been evaluated and what are all the metrics that has been the outcome of all these algorithms. So it highlights the topmost one. So, and it will suggest the best model to be the top one, which has the maximum occurrence of highlights in accuracy, AUC, recall, precision, F1, kappa, and MCC scores. So we see here that the AdaBoost is the model which has given us the best outcome. Now we want to know on what parameters AdaBoost has been executed on. So we'll just do a print of that best model. It will give me what are the parameters that is attributed to this best model. So we can see here that there are number of estimator parameter to be 50 and random state to be 100, learning rate to be 1. So now we get we have just got the best model. The next step being tuned model. So we'll just have to figure out, okay, now we have the AdaBoost classifier to be best. What I want to do is I want to see if by changing any parameters in this hyperparameters in this learning rate or number of estimator or random state, will my model perform better on the same data. So I'm going ahead and tuning the model. What it will internally do is it will do a 10-fold cross validation of different hyperparameters across the data that we have just evaluated on, and it will give me an output of these hyperparameters. Let's just give a couple of seconds for it to run. So you can go ahead and run this step if needed. However, if you don't want to kind of find a tuned model, you are good to go with the best model itself. You can go ahead and do it right away. You can just load this best model and proceed with the prediction part. I've just, for experimental purposes, I've just shown the capability of what you can accomplish with an AutoML pipeline here. Yes, so this is the result of the tune model pipeline, where you'll have the results of the metrics of the 10-fold cross validation setup, and you have the mean metric. So, and what you can do is the next step would be to finalize what model to use, right? So we'll just have to find out what the best tuned model result is. So we can see it here. The tuned model has an estimator number of estimators to be 190 and learning rate to be 0.2, whereas the best model it has suggested had a the best model it has suggested had a number of estimators to be 50 and learning rate to be 1. So it has changed these hyperparameters and then given us a model. We'll just have to compare between them and then finalize which one to use. So one thing we'll proceed next is to find the feature importance plot, making use of the best model and the tuned model that we just got. This will help us kind of visualize what the important features are in two different models. So as we can see here, The plot here kind of gives us an overview telling that this quality parameter 3, 1, 4, these are the primary contributors to the target variable, which is the detergent quality. And the stage QP3 low is something kind of very negligible. And anything less than this is pretty much very negligible, of very negligible importance as well. So we just saw the performance or the feature importance in the best model. We'll go ahead and see the feature importance in the tuned model also. So the tuned model with this hyperparameter suggests that the parameter 2 and 3, similar to what we see here, is the primary feature of importance. The top 4 features being the same here: 3, 1, 2, 4, 3, 1, 2, 4. And once we just visualize the feature importance chart, we'll go ahead and see the evaluation metric, confusion matrix for that, which will help us find or finalize the model. As we can see, this is the true class and this is the predicted class. When the true class is 0, as in if it is bad, the predicted model has correctly identified 64 instances of it and misclassified only 1 instance. Okay, so when it is good, it has identified all the 206 instances to be good correctly, and there are no false predictions as well. So this is with the best model. Let's just evaluate with the tuned model as well, how it is. So the tuned model also gives the same result with the confusion matrix. So it depends upon us if we can go ahead with either the best model or the tuned model. And another one is there is an evaluation model method which will kind of give all the possible visualizations for a particular model. Let's say I've chosen best model here. We can replace it with any model. If you give the tuned model, it will give all the interactive visualization. You can go ahead and click on feature importance, which will give me the feature importance graph, which we just got on the top. And we can go ahead and have an AUC curve, which we can visualize, telling that this is the baseline and all the predictions are well above the ROC, the AUC curve, and the ROC is typically 1, which is very good prediction. Okay, then we have tuned the model, we have compared the model and identified which model is best. Now I'm going ahead and finalizing that. The best model is one I have to do because it has some less number of estimators. So you can either choose a tuned model or the best model. And I'm just validating what the parameters are of the final model. So it is, since we gave the best model, it will be the same. Number of estimators to be 50 and learning rate to be 1. The next comes the predict model or prediction step. So this prediction is totally on the unforeseen data. So this test data is what we had at the start. We didn't feed it into the pipeline yet at all. So we kind of made a split here as train and test. So for the next steps, we just proceeded with the train. Now we have to go ahead with the prediction. And this prediction, this test data doesn't have any pre-processing done already, right? So this, however, the predict model step will kind of handle everything. So now that it has predicted, it is pretty much fast. And I've just got an output data frame. So it has to be 100 totally predictions. I'm just visualizing 10 of it being, okay. So this is the target variable which we just did. So this is the true value. As in the exactly what the label was, and the label is the predicted column value. So the original was bad and it has predicted bad as well, and this is the confidence score of how correctly it has predicted bad. So you can see the same for all the 100 rows as well. And once we have the prediction ready, what I just want to know is, let's say for the model or for the test data which I've just predicted with, I want to know the metrics of it, right? So I want to know what the accuracy is and what the all different precision recall is. So we could just do a check metric and list whatever metrics we want to, and then print it. We could see that it's been 1 all along. It has given 100% great prediction. Now that we have completed the prediction part as well. So this concludes the entire pipeline of AutoML. What we could do next is probably we feel like we'll have to save this particular model, which we just got, because we might lose it if you don't save it with the parameters. So we could, there is an provision already available. What we have to do is just mention on what name this has to be saved, and then choose what model has to be saved. So we are based on the performance, we are saving the best model, and once we saved, we are just evaluating if what the model have been saved works well. So what we could do is we could go ahead and load the model. It is just a pickle file, so we could go ahead and load it. You could see here as well. So we could go ahead and load the model. Once we load the model, we can cross validate again, telling that, okay, previously we did prediction using the best model. Now that I have saved that best model, loaded it again, it has been named as model saved. Now that if I predict with this model saved, does it work well? So I can do that as well and then see if it works. So we could pretty much see that it has given the same label or same outcome. So this will conclude the entire setup of the capability of an AutoML using PyCaret. What we just accomplished is we have just given a baseline model for you folks to experiment on. Yep. So yes, this is what we have right now, and I would we just completed the hands-on session, and the other thing is once you have, you could also sorry, you could also go ahead and create a kit of your own, making use of the AutoML starter, so that you will have a heads up, and then you can mention your GitHub, load your solution into the GitHub, and then mention your GitHub repository in the kit solution source, and publish the kit. Yes.
Excuse me, sir.
Yes, please.
So can you please show once again like how to open Python Jupyter Notebook in Kandi software, sir?
Okay. Yes. Actually, Kandi is kind of an library ensemble. So it's not an IDE. So what you have to do is in your laptop, if you have Jupyter installed, you could go ahead and just type Jupyter Notebook, which will in this directory, so that it will open your Jupyter Notebook. And typically, how you run a Jupyter Notebook, you can open this particular notebook and then run the search. So Kandi is a collection
the repository. You clone the repository, and you will get this Jupyter Notebook in your local laptop or computer.
Okay. Sir, so like even if you do this, even if we solve our solution in normal Jupyter Notebook through our Chrome, it would do, right?
Yeah, that is what you will be doing. So
okay.
Yes. So Kandi is kind of suggesting that you could use Jupyter Notebook for your development, right? So the Jupyter Notebook has to be installed in your machine, and you'll be working on, let's say, Chrome or any browser, making use of this notebook and then submitting your solution.
Yes, if you install this AutoML starter, or if you clone this starter, repository into your local, it gives you maybe a ready-to-use template for your solution, and it helps you fast-track doing all of these steps. Okay, so it's available as an example. You can reuse it and then modify the data set and other parameters like what Ganesh was saying. Or you could, start with a fresh notebook and then do your solution also. So anything works. Even the libraries that we have suggested are the top of the recommendations. If you have any other option that you would like to try for AutoML, you are free to use that library and then put that in your solution kit. And it's not only for AutoML, but for all the other different categories as well, like whatever you have for visualization as well as labeling. Any activity that you do, there is a list of recommendations available in our Kandi kit that is given to you. But apart from that, you can make your own choices. You can use your own, identified library software for achieving that activity. When you submit your solution kit in Kandi, just add that library under the specific section and then mention. Is that clear? Whoever asked that question?
Yes, sir. Thank you, sir.
Thank you.
Great. So this concludes our hands-on. Now we'll be open for more Q&A if there is any.
Arun Kumar, sir, if you have any queries, you can clarify. Okay, thank you, Ganesh, sir. And now we will move on to the problem statement announcement. For that, we have Dr. Somasundram Balasubramanian, sir, who is the Vice President, IAMP Central Council. And he is the business development professional, educator, researcher, with proven and awarded Industry 4.0. He is well versed in digitalization, Six Sigma, lean manufacturing, energy management, system implementation, experience in leading MNCs like Saint Cobain Glass, Valeo, Hanson Drives, JetF, and off-highway transmission business and Siemens. And he is a continuous learner and proud alumnus of IIM, Liverpool, John Moores University, UK, IIT Bangalore, CET Analyst in GPT Coimbatore. And he is a ISO 50000 lead auditor and IEC 62443 Industrial Cybersecurity Assessment Expert and lean manufacturing trainer, Six Sigma Green Belt, senior member in ISA. And he has passed National Secretary of IAMP, which is the Energy Association of Energy Management Professionals. And he is also a life member of Association of Energy Engineers USA, researcher and author of more than 10 scientific publications. And he is currently working in more than 30 plus papers with for 50,000 reads and 8 citations in ResearchGate and all. We are proud to have you, sir, for this launch program. Now I request Somasundram, sir, to take over the session. And please, sir.
Thank you, madam. Thank you. Hello, everyone. So I think you got a feel of what is OpenViewer and how it can support you. Probably, I think more than the platform, you got a grip on what is open source. And if at all you are using an open source library, what are all the precautions you have to take, especially on the community support, the license criteria and other things. I think it's a very informative session, even say for people like me who are working in these kind of solution building. I can also see there is a lot of bubbling energy. I think at least, I don't know in YouTube how many people are live. At least here you have at least 120 participants. Yeah. And I think more than 100 teams have registered for this hackathon. Okay, so great. And I'm also sure, like I also heard it, they have created a helper page, and that helper page has everything for you. If at all you want to jumpstart your application building. I think that is the tagline of OpenViewer. So they help you in say rapidly develop the application so that that application can be say showcased to your customer, and it's not in the business line, it's not a ready-made product that is actually needed by the customer. Probably customer will come up with some requirement and they will request you, can you create a mock-up for that? Yeah. So what we did when we are brainstorming for this hackathon, what problem statement we can give. So we thought like, okay, let's take a real data and with the proper citation and reference to the author of the book, Decision Science. It is there in the link also. You can also cite it whenever you are publishing a paper, probably after building this application. Please cite that particular book. We should be thankful that author have provided us 2 important data sets. Probably, Mr. Naveen, can you flash the screen of that page, please?
Sure, sir. Sure, I will.
Or I think under this is madam. Okay, cool. Not this, ma'am. The Candy page.
Yeah, okay. Naveen, sir, you can
Yes, ma'am. I will go ahead.
Yeah. So we don't want to trouble you with too many handouts and other things. So I think OpenViewer team have done a very good job in making everything available in one web page, so that whatever you need, everything is there. And I think it was I don't know, the session started somewhere around 9 o'clock. Within 1 hour or so, especially the session taken by the last speaker on machine learning, the usage of PyCaret and other things was very informative. Probably he had did something like a wonder, like a Tirukural. So whatever it is there, in 2 lines, Tirukural have written. The same way, the complete machine learning probably it will take a couple of months or probably 6 months to learn. He had made it very short, and he had given you a very powerful tool of automatic machine learning, because it's not necessary every time you have to join a class, then understand what is machine learning, and then go to the next level. What you can do is you can use these kind of packages like H2O, AutoML, say the PyCaret packages, what the speaker shown. Great. So this hackathon is all about energy, right? Energy management. So there are 2 data sets which has been given in this particular page. Mr. Naveen, yeah, please, thank you. Yeah. Data sets. The GitHub repository link. No?
Yes, sir.
Yeah, perfect. So there are 2 data sets. No, yeah, cool. The data set, there are 2 data sets we have given. One of the data set is, if you're interested, say I want to try a problem area where renewable energy is part of it. So this is a rooftop solar data set, and you also have energy storage component in this particular data set. So it is you can refer that book, and there are multiple YouTube videos and the PPTs available in the open web. You can also go through it. This particular data set is having a rooftop solar, and from the solar, the DC energy is stored into a battery, and from the battery, that energy is used by the applications. Okay, so that is one type of data set what we have. And another data set is a typical manufacturing data set. I think this data set is from a very renowned detergent manufacturing company. And I think thanks to them, they have allowed the author to publish this particular data set for the community to have a grasp of how in industry the data will be available. And I take my words, I'm a professional working in industry. I know that these data sets are there in each and every industry. And the biggest problem what all the industry, say managers, they face is they don't have people who can understand this data, crunch this data, and get out with some insights. Okay? So these are the 2 data sets what is given. Okay, and now I talked about insights, right? So if it is a solar or a renewable energy project, the insight what is needed for them is whether this particular say sunshine, what has happened, and the amount of energy which is being stored in the battery, whether it will be useful for the next day. So that is the problem statement for the first data set, and the second data set, I think beautifully it is explained by the previous speaker, that whether quality of the system is okay. We have to think quality as a part of energy. Just imagine if the quality of the system is not okay, then what will happen for that particular material? Can someone raise hand and tell? In a production process, the quality of the material is not good. What will happen for that particular product? Any of the participation team, please?
Sir?
Am I audible? Madam, they can unmute and speak, right?
No, sir. No. I think no.
Okay. They can probably raise hand, and you can unmute any one of them, please.
Yes, sir. Yes, sir.
Yeah. So the question is, what will happen if the quality of a product is not good in an industry? Anyone wants to answer? Oh God, come on! You all are in a hackathon, but you're not speaker, or you're not speaking, or you're not interested to interact. Okay. Fine. See, when the quality is not okay, now what will happen? That material will go for scrap. So just imagine for making that particular product, how much energy might have gone inside, right? So all that energy will be lost if you scrap that particular material. You can do two things. One is a reactive measure, and another is a proactive measure. Just imagine if you are able to avoid, say, 2% of scrap which is generated in a company, then that is a very big energy saving. It is not only energy; it is the image of the company. It is the cost structure will get changed, and energy have to be seen in that particular angle. Otherwise, what will happen? People with energy analytics interest, they will be probably silent, or they will say like, okay, energy, you change the bulb from LED to blah blah blah. Then those things will not work. It will not sustain. It will not give you a big stage. So if you have to work in a big stage, probably you have to go inside the production data. So for have a feel of that particular production data, we have given the detergent manufacturing data set. So with this particular data set, what you have to achieve, right? That is what the hackathon is all about. Mr. Naveen, kindly scroll up. So there are 4 tasks in this particular webpage already given, and beautifully there are examples where you can jumpstart and use it and take it to the next level, right? So there are 4 important things what you have to achieve. What the data is all about. So in analytics, it starts with descriptive analytics. That means you have to first take the data and give a dashboard where the human expert is able to analyze that particular data set by his naked eyes in terms of probably a very good dashboard, a KPI dashboard, where he can slice the data set, dice the data set, drill down, drill up, and all those things he can do. Normally in IT terms, it is called as OLAP, online analytical processing. So that is the first step what you have to do. Now, when this particular data is available for the expert in a dashboard, probably another teammate, he can concentrate on how this particular dashboard data can be analyzed by the operator or the human expert. But what will happen? There is a very good talk on unbalanced data set by the previous speaker. That is a big problem in the industry. So why this unbalanced data comes? Because there is no proper labeled data available. But just imagine each and every expert, whenever he is testing the data, he will have some insight. But what will happen? It will come inside data. So repetition and now when annotation and labeling feature you have to give human capabilities. It is not like say a very big data set. One person can go through it and he can come out with abnormalities in the pattern of the data. So you have to help him with some tools which will be able to analyze the pattern and statistically come out with say there is some strange pattern in this particular area. In energy management system ISO 15001, we call this as any significant change in the KPI of energy have to be properly investigated. It can be on the positive side, it can be on the negative side. If energy performance is too good, that also has to be investigated. Why it is too good, so that the good can be served. Right? Energy data, if it is obviously it has to be investigated why it has gone low and how to avoid it in the future. So this particular patterns, that is something very important. Algorithms like change point analysis, principal component analysis, those kind of algorithms can be used under the in the bottom. Now, I have an annotated data. So with this annotated data, I know which pattern of data is good, which pattern of data is no good. Then you can go inside the prediction. So in analytics, as I told you, descriptive analytics is the first step of analytics. That is an expert of diagnosis by a doctor. The same way, the expert diagnosis what is happening in the cost. Now the next level is predictive analytics. That means if the operator or the expert who is able to identify a problem with the pattern change in the data, what same laboratory doesn't have to give once again, right? So that is the support what we can give in terms of for the energy management professionals. So that is the second thing. Is the predictive, or the third thing is the predictive analytics, where you create a machine learning algorithm which will learn from the expert analytics time when the new data is given. Advanced stage is prescriptive analytics. Probably, if some of the team can go to that particular level, I don't know, then the judges have to make a very good decision that they are the best. So basically, what we are thinking is not only a mere dashboard. We are from India and new generation, right? In my generation, having a dashboard itself is a very big challenge. But now, every street has a software company who is able to give a very good dashboard. Even in our hotels, say your Ola, everything is having all this. But how you can stand out of the crowd is by giving an intelligence for your application. And intelligence to the application, one is the user comfort by means of helping the expert to better annotate the data which is being fed inside. And second is only once or twice the expert have to give his feedback. After that, the machine have to be in the auto mode. That means the algorithms have to be built in, which will replicate the expert annotation maybe next time, and it will automatically create an exception-based alert to the people that something is going wrong in your energy KPI. Please come in. So what will happen, instead of a reactive measure after a problem happening during the postmortem, what we are going to do, nothing, very minimal. Maybe in future we will avoid it. I don't know when that future will come. But if you are able to take a reactive step, then you can act upon it and avoid something which is happening to you. Yeah. So this is the challenge what we want to give to the hackathon participants, and thanks to the sponsor and the OpenViewer team and the community and all the CTO, Mr. Karthik, who have put a lot of efforts in guiding his team in making this beautiful page with a lot of open source tools which is available for realizing this particular task. All the best to everyone. Probably I and my colleagues will be here. I have a data scientist in German MNC who is also part of this particular thing, and we have energy managers and energy auditors from IAMP. They will be pitching in and out, and Madam and her team, they will also pull in whenever you guys got stuck up and probably you need some support from us. Yeah. So all the very best for the participants. Over. You, madam. Madam, you are able to hear me?
Yes, sir. Yes, sir. In between, some network issue was there, I think so. So thank you, sir. Thank you for giving a wonderful introduction about this one. And this is the problem statement, and these are the expected outcome in the application. Am I correct, sir?
Yes, ma'am. Yes, that is the expected outcome. So the OLAP operation, yeah, all these things you have beautifully captured. Yes. So this is a wish list. Probably, if everyone is able to achieve that particular wish list, then it would be great. And probably based on your presentation and how well you have built the solution, that is how the jury will judge it. Yeah.
So participants, if you have any queries related to the problem statement, you can please unmute yourself and ask the queries. Sardak? The teams which are all meeting this expected outcome in the file submission. So they will be considered for the NS selection. And you are requested to submit your solutions in a Word document or PDF file, mentioning all this, which are the library packages you have used and all. And in the form, there is a separate link for submitting your Candy kit also there. So tomorrow, 10 o'clock is the timeline for submitting your solutions. The link will be shared in the WhatsApp group. If you have any queries related to this problem statement or related to the Candy software, you can post it in the WhatsApp group, or else now also you can clarify. All the resource persons are here. They are ready to help you. Guys, any queries?
No, ma'am.
Okay, fine. So the data sets and everything is given in the Candy kit openware software. So we will share the link for in the WhatsApp group also. You can just open it. Your time starts now. Thank you once again. And on behalf of VIT management, the coordinators of this hackathon, myself and Dr. Jamna ma'am from VIT IAMP student chapter, we thank you once again, the IAMP members, Nilamegam sir, Somasundram sir, Ashok sir, and Sahana madam, Google sir, for helping us in framing this all this problem statement and all. And we thank the team of OpenViewer, Naveen sir, Saravanan sir, Karthik sir, John sir, and Lakshmipati Ganesh sir, everyone from OpenViewer team to sponsor this event and also to have the cordial relationship throughout the progress. We thank once again, and as mentioned in the mail, the file submission should be completed before 10 o'clock of tomorrow, and the shortlisted teams will be called for the PowerPoint presentation on 11th evening, and then the prize announcement will be taken on 12th evening, 7 o'clock. All the links will be shared in the group, and thank you once again. Thank you, Sumu sir. Thank you, ma'am.
Welcome, madam. All the best.
Excuse me, ma'am. Excuse
Yes.
me, ma'am.
Yeah.
Yes, sir.
Ma'am, submission link will be provided on the WhatsApp group itself, right?
Yes. We will share.
Okay. And also we have to upload our files on Candy software, ma'am.
Yes, you have to upload the files and share the Candy link in the submission link.
Okay, ma'am. Fine.
Yeah, and actually every team has been assigned with a team number. That link also, that PDF also shared in the mail and in WhatsApp group as well. So for your team, the team number must be mentioned in the file submission stage. Any other queries, ma'am?
No, ma'am.
Thank you, participants. Thank you for joining with us. And next we will meet on Wednesday. Thank you all.
Ma'am, this meeting's recording will be available on YouTube, right? In the link, right?
Yes. It will be there.
Okay, ma'am. And one more doubt, ma'am. Should we report in some time intervals or something, or just submit the final thing tomorrow?
Time interval means?
Means in some hackathons, they will ask us to report within 1 hour, some members to the...
Not like that. Everything has to be submitted in the link by end of the hackathon, like before 10 o'clock tomorrow.
Okay, ma'am.
Yes.
Ma'am, are we supposed to leave the meeting now, or present?
Yeah, we can leave. Okay. We'll close the session. Yeah. Thank you all. Thank you once again. Officially, we are closing the meeting.
Thank you, ma'am. Thank you.
Thank you, Naveen sir. Thank you, everyone.